Circles and lines. If you have a circle and a line on the same plane, there are three different scenarios. They do not intersect, they intersect exactly 1 point, or they intersect at exactly 2 points. Let's look at an example of each. So a circle and a line that lie in the same plane can intersect at 0 points, so there's no intersection. 2. A circle and a line that lie in the same plane can intersect at 1 point, so there's 1 point of intersection. Circle A, line M. We call this a tangent line. A tangent line is a line in a plane of a circle that intersects the circle in exactly 1 point. And in this case, it's point D. We call that point the point of tangency, the point where a circle and a tangent intersect. So we would say that line M is a tangent line to circle A at point D. The third scenario is a circle and a line that lie in the same plane can intersect at exactly 2 points. So there's 2 points of intersection. So we have line CD intersecting circle A at point C and point D. We call that a secant line. So secant is a line that intersects a circle in 2 points. And if you notice, any secant includes a chord. So CD would be a chord of circle A, but it's part of a line, and that line is called a secant line. So let's find tangents and secants. So again, tangent is a line that intersects the circle at exactly 1 point. So if I look at the different lines, I see line AD, that doesn't intersect at all, but I do see line AB intersects the circle at 1 point. It's not labeled there, but that would be a point of intersection. And also GE intersects circle C at exactly 1 point. So the tangents would be line AB and GE. And we have them in yellow. And secant lines are lines that intersect a circle at 2 points. So look at the other two lines. We've got BG, it intersects here and at point G. And we also have DH intersects at H here and some other point right here. So our secant lines are BG and DH. So with that, let's introduce the tangent theorem. Okay, the tangent theorem states that a line that is tangent to a circle is perpendicular to a radius of the circle at the point of tangency. All right, so we have a tangent line. It intersects this circle at this point right here, this point of tangency. And if we draw a radius from the center to that point of tangency, then we will automatically know that that radius is perpendicular to that tangent line. So again, if you have a tangent line of a circle, the radius drawn from the center to the point of tangency is going to be perpendicular to that tangent line. And the converse works as well. So, think about this. What can you draw when you have a circle, right? A line, tangent line, and a radius at the point of tangency? You see you have a right angle there. Well, what could we draw? We can draw right triangles. And with that, we know things about triangles and right triangles that we can then find missing angle and side measures, segment measures. So let's take a look. All right, so let's use the tangent theorem. Line BC is tangent to circle A at point D. So what does that tell me right away? That radius AD is perpendicular to segment CB because that's a tangent line and that's the radius meeting at the point of tangency. So what is the measure of ADB? It's a right angle. Right angles measure 90 degrees, so that is a 90-degree angle. Now they want us to find the measure of angle ABD. Well, that is the third angle. What are the three angles in a right triangle? They told us this angle here is 35. We know this one is 90. So we use the triangle sum theorem And we're going to do 180 minus the sum of 90 plus 35, and that will get us 55 degrees. So angle ABD is 55 degrees. And if we simplify, this would be 180 minus 125 equals 55 degrees. So again, we're using the triangle sum theorem and the fact that we knew that we have a right triangle here to find the missing angle measure. All right, let's try one more. How about we use it to find segment lengths? In the diagram shown, line SR is tangent to circle O. If OT is 9 centimeters, I'm just going to put the numbers here, and TS is 6 centimeters, they want us to find SR. Okay, so again, if SR is tangent to circle O, OR would be a radius, therefore that would be a right angle because that tangent will be perpendicular to the circle at the point of tangency. Okay, and then this side, OS, would be 15 because 9 plus 6 is 15. So we have a right triangle and we know its hypotenuse and one of its legs, so we can find the other leg measure using the Pythagorean theorem. So in this case, 15 squared, minus, I forgot to, one other thing. So one more thing here, hold on a second. I forgot to label the other thing. All right, so we need the measure of OR. Well, if OT is 9 centimeters, then so is going to be OR because they're both radius. They're both radii, and all radii of a circle have the same measure. So now we can use the Pythagorean theorem to find the missing leg. So we're going to do 15 squared minus 9 squared equals x squared. Okay, this is the hypotenuse is 15 squared, that's 225, minus 81 squared, the measure of one leg, 81 equals x squared. 225 minus 81 is 144 equals x squared. Take the square root of both sides, and we get x equals 12. So SR is 12 centimeters.